let's start with the big, obvious question. Does AI actually think? I mean, when you talk to a chatbot, it replies in these beautifully formatted paragraphs, right? It remembers what you said 2 minutes ago. It feels alive. It feels conscious. But here is the mind-blowing secret we're going to uncover today. Despite feeling so incredibly alive, the AI doesn't actually even know what a word is. It literally only knows math. AI does not possess real thoughts, it has no intentions, and zero consciousness. It doesn't have emotions, and it definitely doesn't understand the world the way you and I do. What it actually does is something entirely different, but mathematically, it's just fascinating.
So here is our lesson plan for the day. We're covering 6 main parts. First, the illusion of AI thinking. Second, how neural networks predict. Third, 2 methods of AI logic. Fourth, the AI analysis pipeline. Fifth, techniques of artificial reasoning. And finally, number 6, calculating versus real understanding. Let's just dive right in.
All right, part 1, the illusion of AI thinking, breaking the spell.
Okay, to really break this spell, I want you to think about your smartphone keyboard for a second. You know when you're texting a friend and the phone magically suggests the exact next word you wanted? Well, it isn't reading your mind, it's just recognizing your typing patterns based on stuff you've typed before. Modern AI is essentially that. It's a super advanced autocomplete system, just millions of times smarter. But how on earth did it get that smart? Well, it essentially read the entire internet. We are talking about way more text than a human being could possibly read in 10,000 lifetimes. And because of this massive, massive scale, its autocomplete isn't just guessing letters anymore. It is guessing complex human-like ideas. It's not pondering your question at all. It's just efficiently predicting the most likely response word by word.
Moving right along to Section 2, How Neural Networks Predict, the Mathematical Basement. To truly understand how AI predicts things, we have to define its core engine, which is the neural network. Now, this is a pattern learning architecture, and it is so absolutely crucial to remember that this is not a biological brain, okay? And it's not a database either. It doesn't store facts like an encyclopedia that you can just open up and read from. Instead, a neural network is this highly structured data processing system that stores the relationships between things. By training on just massive data sets, these neural networks learn complex language patterns, context relationships, and cause and effect associations. And this huge web of mathematical relationships is the absolute foundation that allows AI to simulate reasoning.
So let's walk through the exact sequence of mathematical events that kicks off the very moment you type a prompt into an AI. Let's say you type, "the cat sat on the..." Step 1 is input understanding. The AI doesn't actually read those words, it converts your text into long lists of numbers, which we call vectors. Step 2 is context processing, and this uses something called the transformer architecture. The AI looks at all your words together to figure out the context, like, hey, are we talking about a fluffy pet here or a jazz musician named Cat? Step 3 is prediction. The AI mathematically calculates what the most likely next word should be based on those billions of relationships it learned. And finally, step 4 is token-by-token generation. It literally spits out the word mat, building its answer one single piece, or token, at a time.
If we peek just a little bit deeper into that transformer architecture, we find 3 really critical components that make these predictions so startlingly accurate. First up, we have weights. These determine the actual importance of the connections between concepts. Second are layers. These represent different stages of processing. So moving from super basic grammar at the bottom layer, all the way up to complex abstract concepts at the top layer. And third is the attention mechanism. You can think of the attention mechanism kind of like a super diligent student highlighting the most important words in a really dense textbook. It allows the AI to remember the crucial setup at the very beginning of your long paragraph by the time it finally gets to the end, ensuring that the context never ever gets lost.
Which brings us to Section 3, 2 methods of AI logic, the AI brain structures.
Now, historically, there have been 2 totally distinct methods of AI logic. First, we have modern connectionist AI. These are the neural networks we've just been talking about. They learn patterns from billions of examples to make statistical predictions. You can think of connectionist AI like a highly intuitive artist who studied a million different paintings and just naturally intuits exactly where the next brushstroke should go. Then, on the other side, we have symbolic AI, which is often called good old-fashioned AI. This relies on explicit, highly precise if-then rules. Think of symbolic AI kind of like a remarkably strict math teacher, where 2 plus 2 must always equal exactly 4, no exceptions.
Symbolic AI is incredibly precise, but it's very rigid. Connectionist AI is super adaptable, but at the end of the day, it's statistical. Modern systems actually often blend these two approaches together to solve the really messy, unpredictable problems we have in the real world.
Let's move to Section 4, the AI analysis pipeline, processing the world.
So what happens when you hand an AI some fresh, real-world data to analyze? Well, it doesn't just look at it. It processes that information through a very strict three-step pipeline. First is data representation. Just like with language earlier, AI converts whatever you gave it, images, charts, text, straight into vectors. It essentially turns messy, real-world concepts into clean math. Second is feature extraction. This is where the AI identifies the actual signal hiding inside all the noise. For example, if it's analyzing a handwritten note, it learns to completely ignore the smudges and the coffee stains, focusing only on matching the curves of the ink to known alphabets. Or in a financial analysis, it might ignore what day of the week it is, but focus intensely on interest rate changes. Finally, the inference engine kicks in. It takes its prior training and applies it to this newly extracted data, looking for correlations or anomalies that match its mathematical map of the world.
All right, Section 5, Techniques of Artificial Reasoning, Frameworks for Logic.
Let's explore an incredible matrix of reasoning frameworks that AI uses. AI can flawlessly simulate deductive reasoning, which is applying a general rule to a specific case. Like knowing Socrates is mortal simply because all humans are mortal. It also simulates inductive reasoning, finding patterns to form general rules, like, hey, every time I've seen a cat, it purrs, therefore all cats purr. It heavily utilizes what we call chain of thought, where it breaks a complex math word problem down into much smaller sequential steps. And it even simulates abductive reasoning. That's guessing the most likely explanation for incomplete facts. Like, if the ground is wet, it logically reasons it probably rained, though I suppose a very enthusiastic dog shaking itself off is technically statistically possible too. But remember our foundational lesson here, right? The AI is performing these highly human reasoning frameworks using nothing but cold, hard statistical probabilities.
And finally, Section 6. Calculating versus real understanding. The ultimate difference. We really have to draw a hard line here and separate human thinking from AI calculating. Humans use intuition, conscious efforts, and our actual biological experience of living in a physical world. AI relies entirely on high-dimensional math based on its training data. Think about it like this. When an AI writes a beautiful, poetic description of a heavy object falling to the floor, it isn't vividly imagining gravity. It's not picturing the object in its mind's eye. It is simply executing high-dimensional math to calculate the overwhelming probability that the word falls perfectly follows the description of a dropped heavy object. It calculates beautifully, it really does, but it absolutely does not understand.
But listen, the frontier of this technology is expanding incredibly fast. The future of AI actually relies on a concept called test-time compute. Newer models like the O1 or O3 series are being designed to actually pause and think before they generate their tokens. They run multiple internal simulations, they check their own logic for errors, and they literally discard paths of reasoning that don't make statistical sense before they ever show you the final result. And why does this matter to you? Because this simulated self-correction is exactly the thing that turns AI from a simple writing assistant into a massively powerful entity capable of solving high-level coding, logical, or mathematical problems that it has literally never even seen before.
Which brings us to our final slide, and a question I really want you to take with you long after this explainer ends today. If an AI can flawlessly simulate logic, reason, and problem-solving without a single shred of consciousness or real understanding, does it actually matter that it doesn't understand? I mean, if the output solves your most complex problem, does the lack of a biological mind behind it actually change its value? It is a deeply profound philosophical question to ponder as these massive probability engines become more and more integrated into our world. Thank you so much for joining me for today's explainer, and keep asking great questions.